introduction, the Smart Irrigation System is a system that using Arduino IDE and IoT platform to control the system to irrigate the plant. It will automatically irrigate the plant based on the level moisture. Furthermore, it is using soil moisture sensor to measure the actual moisture. Next is problem statement. For the traditional irrigation system, the saving is not considered. The reason is water will irrigate directly to the plant without right amount, then become the plant appearance is reduced. For objective of this project is to design an irrigation system and monitor the data using link application, and to analyze the soil moisture using link application. Okay, next is scope of research. This project is paradigm shift from manual irrigation to automatic irrigation. Sensors are used such as DHT11, which is temperature and humidity sensor. Relay module. Literature review for this project. In the current area of globalization, the smart irrigation system is modern than the traditional irrigation system. Smart irrigation system is the combination of the advanced technology of the sprinklers. We will measure the pH of the soil. Basically, the range pH of soil for plants is about 6.5 for components. The main component that we use is Node MCU. Node MCU ESP8266 is an open source based firmware and development board specifically target for IoT based applications. Node MCU has 1 to 8 KB RAM and 4 MB of flash memory to store data and programs. Second is soil moisture sensor. The soil moisture sensor is used to measure the volumetric water content of soil. As well as it can use in measure that moisture of the soil and automatically irrigate the plant. DHT11, which is temperature and humidity sensor. The DHT11 is a basic ultra low cost digital temperature and humidity sensor. It uses a capacity humidity sensor and thermostat to measure the surrounding air and spit out a digital signal. Next, 2-channel 5 relay module. The relay module is a separate hardware device used for remote device switching. With it, you can remotely control device over a network or the internet. The relay module houses two SPDT relay and one wide voltage range optically inserted input. The relay uses an electrical current to open or close. Lastly, component is water pump. The water pump push coolant from the radiator to the coolant system into engine and back around the radiator. Methodology. This chapter will cover the detail of the project design, cost of this project, data of the rainfall in Malaysia, and the component that used in smart irrigation system. Once completed, this project can automatically irrigate the plant with referring the moisture of the soil detected by the soil moisture sensor. In order to make this project become successful, the methodology covers the project design and the procedure to build and develop in this project. Next, we identify the types of components or materials that we use in this project. Then we do a simulation by using previous aid, profession, and writing the Arduino source code in Arduino software.
Am I going to present about the smart irrigation system for the flowchart? First of all, the smart irrigation system will connect with the power supply and the Node MCU ESP8266. It is a microcontroller and it will connect with the hotspot. DHT11, it is a temperature and humidity sensor. It is detect the humidity and temperature surrounding area. Put the soil moisture sensor into the soil and it will detect the soil moisture level. Then the data will send to the Blink app. If the soil moisture level is below than 20%, the relay module will on and the water pump will on. If the soil moisture level is above than 20%, the relay module will off. So for the next part is design of project. This project we have used the components such as water pump, Node MCU ESP8266, 2-channel relay module with 5 wood, DHT11P, and soil moisture sensor. Next, it is a circuit for the smart irrigation system that we use the software to create in PCB mode, using the soil with the pH value around 6.1 to 6.5. The temperature required is around 10 to 25 degrees Celsius. The watering required is once a week. Second plant is Pilia depressa. It is using the soil with the pH value around 5 to 6. The temperature required is 12 to 26 degrees Celsius. The last plant, Sansevieria trifasciata, or we call as snack plant. It is using the soil with the pH value around 4.5 to 8.5, and the benefit is filter the indoor air, and it needs the direct sun to grow well. Next is data analysis. The result that we record is using 3 types of plant with 3 days, morning and night. We can see the difference temperature, humidity, and soil moisture level with 3 days from morning to night. Next is impact of project. First is, it will be effective about the person who like gardening. Second, it will automatically irrigate the plant. Last is, we can use the Blink app to control or watering the plant. For the last part in this smart irrigation system is recommendation. We will try to improve our smart irrigation system that can use a lot of plant with the same time. And the last is, we will improve the smart irrigation system with the lowest cost.
In conclusion, which plant need more moisture and humidity? The plant is Pilia depressa. This is because the temperature that required for this plant is between 12 degrees Celsius until 26 degrees Celsius, and humidity is high humidity, which is around 60% to 19%.